ta 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 ta. All right, stream seems to be going. Capture's okay. Microphone's okay. All right. So good morning. Today we're going to be doing Advent of Code Day 3. But before that, let's do a quick recap, I guess. So we're solving Advent of Code in Livebook, in Elixir Livebook. This is sort of a website, this is a notebook implementation in Elixir. It's pretty nice in that it lets you experiment with things fairly easily. It also kind of looks nice on stream. So far, we've done day 1 where we got thrown out of a trebuchet, and then day 2 where we played some sort of inane game with colored cubes with an elf. Yesterday's solution involved us writing our own little parser. I think I called it a recursive descent parser yesterday, but really it's a lot hackier than that. Still, it gets the job done. It parses the game input into some nice data structures, and then we can just easily process the data structures to solve the two parts. We also tried using Nimble Parsec, a parsec combinator library, and although it worked and the result doesn't look particularly bad, this is, well, let's just say this wasn't very fun to write. And it doesn't look much better than, the manual implementation. If I had to pick which of these I find in a code base somewhere that I have to maintain, I'd much rather have the manual parser implementation there. Okay, so that's the recap. So without further ado, let's go to day 3. Let's see what's in store for us today. Okay, day 3, gear ratios. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Okay, so we're still trying to figure out why there's no stove. For that we need water, and I guess to get to the water we need to go up the gondola. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. Of course, we offer to help. This is just the sort of thing we do. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which is missing. Okay. The engine schematic, your puzzle input, consists of a visual representation of an engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. Here is an example engine schematic. Okay, so I guess we have this grid of symbols. Some of the characters are going to be digits, some of them are going to be dots, and some of them are going to be symbols. And we have the engine schematic. There are lots of numbers you don't really understand, but any number adjacent to a symbol, even diagonally, is a part number. So I guess the part number for star is then going to be 735. In this schematic, 2 numbers are not part numbers because they are not adjacent to a symbol. 114 top right and 58 middle right. Every other number is adjacent to a symbol and is a part number. Their sum is something. Oh, so it's not just the digit, it's the full number. So the part number here is 46735. But 114 is not because it's not adjacent to a star, or a plus or a hash. And 58, middle right. This one is also not a part number. And everything else is? Yeah. Okay, of course, the actual engine schematic is much larger. What is the sum of all the part numbers in the engine schematic? Okay, so how do we do this? We're going to need So we're going to need to represent the grid somehow. We can just store it as a matrix, but what does our actual puzzle input look like? It's a big grid, but again, it's mostly dots. Yeah. It's mostly dots, so we can definitely store this in some sort of sparse way. We don't necessarily need to hold the whole matrix. Although we could just have the matrix. And then we're going to need to find all of the part numbers. Parsing the numbers isn't going to be particularly hard because they're just the consecutive spans of digits. But then the question is which ones are adjacent to a symbol and which ones are not. If a number is adjacent on the line, it's pretty easy because we can just go through the line in order, and yeah, if we have a number and then we have a symbol, or if we have a symbol and then a number, then that is a part number, and otherwise it's not. But how do we do? We also have to handle numbers above and below symbols. All right, so the way I'm thinking of doing this is to just store a map of numbers and their, well, I think we want to have a list of numbers and their coordinates. And by coordinates, I mean their whole span. So this one would be line 0 and then characters 0 through 3. And this one would be 114 associated with line 0 and characters 6 through 8. And then we go through the matrix again, find all of the symbols, and then check the entire matrix for numbers whose coordinates are adjacent to this. And in fact, since we can have numbers below the symbols, since we can have numbers both before and after the symbols, this means we can't do it all in one pass. So we'll definitely need to store something. And I'm going to pick storing the numbers, because that seems like the most sane approach. Okay, let's get going, I guess. Let's get going. So new notebook. This is going to be called AoC 2023 Day 3. Let's save it to make sure we don't lose this information in some horrible accident. As always, first section is going to be called helpers. Then we're going to have part 1 and part 2. Part 1. We're going to add Kino as a dependency because we're going to need to read our input somehow. Yep. Reconnect and setup. Yep, we already have it. All right, so helpers. Based on past days' experience, we're going to need both. We're going to need to store both the example input and the actual input. So example 1 is kino.input.text area. Example input. Yep. And then we're going to need another one of these for the actual input when we get to it. Input is kino input text area. Real input. Yeah. Okay, our example input is this thing. This should just work. I'm going to clear my clipboard to avoid an unfortunate bug in Livebook. Right, so can we read our input? Input read example 1. Yes, we have it. Do we want to split it into lines? We probably do. So we're going to do string split on new line. Okay. I also noticed yesterday that, yeah, if you have a trailing new line at the end, then you get this empty string at the end. So let's just trim. Right, and now we no longer have the empty line. Okay, so now next up, I said we want to parse this and get all of the numbers and their positions on the matrix. So first off, we're going to need the line numbers. Is it a num with index? Yeah, okay, a num with index, we now have line numbers. We're going to fold. No, we're going, for starters, what we want to do. So ultimately, we're going to need a fold here because we're going to be accumulating a map of numbers and their positions. But while we're developing it, let's just do it with a map because that's easier to think about. We have line and I. And right, and if I just output line, it shows the line, of course. All right, so now we have a line. This is a line. We want to go through the line and find all of the numbers and also keep track of their positions. So, well, let's call it find numbers. Find numbers of line. And we need to put this in the module because Elixir really doesn't like top-level functions. And lines. This is going to be a binary. Let's just say string length of line. Does this output something nice? Function find numbers 1 is undefined. Oh, find lines, find numbers. And wait, why did this not return anything? This just returned, oh, so this is funny. It returns a chart list of new lines, but new line happens to be the binary, the character for 10. So it just thinks that this is a string of new lines, but really it's just a list of the number 10 repeated again and again. If I do +1, it's probably, yeah, it's going to be some other character. Right. I still want to actually see it, just to avoid any surprises later. Yeah. Okay, 10. Everything's okay. Good. So we have a line. We now need, how does this start? So if this starts with a digit, then we want to consume it. Then we want to go into parsing numbers. If it's a dot, then we just want to skip it. Oh. So we're going to need to keep track of our position in the line. So find numbers of line is just going to call find numbers of line and 0. And this will be our actual function. Line and index. Right, and what is our line? So I said if we start with a dot, I can just do it like this, can't I? Rest binary. So if we start with a dot, then we just keep on going. Find numbers of rest and idx +1. Now, and actually, we're going to need an accumulator here, aren't we? Well, we can return it as a list, right? So let's say that this function is going to return a list. The base case is the easy thing to talk about. So if we reach the end of the string, or if we reach an empty string, then we just return an empty list. Okay. And now we just need to find. Now, what happens if we have a digit, a character? Sorry, a digit, not a character. So if we have C and rest binary, and we have an IDX, of course, and C is in, and C is a digit, then we do something. What do? We need another, yeah, we need another parameter here. So the third parameter is going to be current. And if we get a dot, current is going to get reset. Current is going to Oh dear, this is going to be a mess to describe. Okay. So, if we find a dot and our current thing is 0, then we just keep on going. If we find the dot and our current thing is not 0, and it's not 0 because we've already matched on the 0 above, then we return a list with current prepended and then whatever other numbers we find. And not just current, we want IDX and current because we need to know the position where current ended. Yeah, we're going to need the position where current started as well, but we'll do that a bit later. Okay, then if we find a number and it's a digit and we have a current, then we're just going to call find numbers of rest, because we're going over everything else. We always increment the index, and current is going to be current times 10 plus c minus the character for 0. So we're turning this ASCII char into a digit here. Right, then this is going to keep on going until we eventually reach a dot, at which point it will get prepended to the list. And then when we reach the empty string, then it will be nothing. But now that I think about it, what we want is not actually a dot, because we have all sorts of other symbols as well. Like a star, yeah, as we can see here, a star also terminates a number. So really, this should be the first case, although it's not really the one you think about. And then here, instead of a dot, we have any character. Any character that is not a digit, because we already did the digit case above here. Yeah, and we're not matching on IDX or current in any way, so any digit will get caught by this, and anything that isn't a digit will get caught by these two cases. And then that's the base case. Right, and here, let's return I. Okay, how does this work? Clauses with the same name should be grouped together. Yeah, fine. Undefined function find numbers 2. Where do I have a find numbers 2? I should only have find numbers 1, line 7. This is hard to read because it's all on one line. Let's break down to multiple lines. Right, this is... So what's this? So this has to be 0, right? Because we've already found this is a non-digit, so we've emitted the number, and then we want to continue without the number. And find numbers, no arguments here. This also needs an IDX and a current. And we need to handle the case. So if the current number is 0, then we don't emit anything. But if the current number is something other than 0, then we want to emit it as a list. This is probably what the error earlier was about. Okay. IDX is not used. Right, we have to, I said we wanted to emit IDX and current, right? Okay, so we have line 1. There is, let's flip these things around so that we emit the number first, because that's how I'm going to be reading these. Cur and IDX, and here we have cur and IDX. Okay, so line 0, we have 467 ending at 3. Yep. Then we have 114 ending at 8. Is that right? So that's 4, 5, 6, 7, 8. All right. Then there's nothing on line 2, and on line 3 we're going to have 35 ending at 3? At 4. Is it 4? 0, 1, 2, 3. Oh, so I guess IDX is showing, yeah, this should be IDX minus 1, because the number ended at the previous position. Right, so 467 ending at 2, and then 35 ending at 3. And then 633, 617, 58, 592, 755, and then on the last line, 664 and 598. 664 and 598. Okay, this kind of works, but we only have the ending position of every number. We really wanted the starting position as well. And to do this, we're just... Why is this underlined? Okay, we weren't using IDX. Okay, so we're just going to make the pattern matching here even more convoluted. Yeah, so instead of 0, do we want a 0? Yeah, we want to start with a 0. What do we want? I think I wanted the third argument here to instead of being just a number, to also be a number and a starting position. So 0 starts at 0 and 0. And then here, this is going to be start and current. And when we keep on going, it will still be start and current. So we don't need this to be a tuple. I really wish Elixir had the named arguments at this point, because this is going to be kind of funny, or this is going to be a bit hard to understand. All right, so start and current. All right, so if this is the case where we're adding a digit to the number. So we just leave start as it is. Then in this case, this is the case where we haven't found a digit and we're also not in a number at the moment. In which case, we don't care what start is, because start is just going to be IDX plus IDX. Right? Yeah, I think it's IDX. Then in this case, what's this case? This is the case where we found something that isn't a digit, and then but we had something stored in our accumulator. So in this case, we're going to emit cur and start, and then reset start to IDX. This is the case where we are at the end of the list and we had nothing in our accumulator, so we just return an empty list. And this is the case where we are at the end, but we did have something on our accumulator, so we're going to add start here. All right, so let's see if this works. 467 going from 0 to 2. 467 from 0 to 2. Then this one should be 4, 5, 6, 6 to 8. It should be 11468. 11448. 47. Why is this a 4? Is the 4 correct there? Probably isn't. So what should the number be? 4, 5, 6. It should be 6. So we're not incrementing start somewhere. Here. Here? Yeah, we're not incrementing start here, but that's fine. Here, should this be index plus 1 by any chance? Five, 7, 4. No, it should definitely not be, or that's not quite, maybe it should be plus 1, but that's not the recent thing to do here. So we have 4, 7. Why is start 4? Start only gets assigned. Where does start get assigned? Start gets assigned, so this is 0. It starts at 0, that's fine. Then if we're currently adding to a number, it doesn't change. Right? Yes, because this is the only case where we're adding to a number. So then here, this is the case where we're moving forward without, yeah, this is the case where we're moving forward without adding to the number. This should just be IDX. And then the first time we're going to be in this case, and then at some point, and then we find here. Then we're going to get into the first case. at 1. And at that point, we're just going to store the start. We're just going to start keeping we're going to keep the start value unchanged. Right, so this start value should not actually be start. This should be idx plus 1 here. This should, or rather, this should be idx. We don't care what the start value is. No, we do care what the start value is because this is the first time, in the first case. So this should be idx plus 1 here. This is the right length, 5, 7, 5, 6, 7, that's 3 digits. So am I just miscounting this? 0, 1, 2, 3, 4, 5. Oh, I am just miscounting. So this is indeed 5, 7. And this one should be 2 to 3. 2 to 3, right? And the other one is 6 to 8. So this is 3, then this is 4, 5, 6, 7, 8. 6 to 8. All right, this works. This is correct. Right, what's this IDX here? This is the case where so this is the case where we've just finished a number. And honestly, it doesn't even matter what the start value we put here, because we know that the next thing is not going to be a number. So we're guaranteed to always start a number out of this case. Yes, we have to start a number out of this case because otherwise we'd be adding to a number. So honestly, this could just be nil. Nil? Ah, and there's a nil value here, so good thing I checked. Okay, so IDX. Wait, how are we in this case at the very end? We're in this case at the very end because... Oh, because we can also add to... Right, we can also add to the results at this position. So is this correct? 59847. 598, and it should be 1, 2, 3, 4, 5. 5, 6, 7. It should be 5, 7. 4, 6, 7, 8. Yep, this is wrong. So this here should be a plus 1. 5, 7. Good. All right, so where are we? We are currently in the state where we have gone through the input and found all of the spans of numbers. So next up, I want to turn this into, well, honestly, it will be a list because we're just going to be iterating over it. Will it? No, we're going to make a map from line number to spans. Yeah. So actually, I want to structure these slightly differently. Right, I want all spans to be tuples. Just to make it clearer that one thing's a number and one thing's an index. Right, so this is a number and then these things are indices. Number, indices. Okay, and now our map here becomes... Oh, we're just going to do enum into map. Okay, so now we have a map. So now we can easily find all of the spans at line 0, and then all of the spans at line 1. All right. Then we're going to be going over the text twice. So let's just say text is this, and then text type into. Right. And then we're going to call this what? Well, I've been calling them spans, so I guess they're called spans now. Spans. And spans still computes correctly? Yes, it does. So text, we do the second parsing. We do the second iteration. We can split it into strings, into lines here, because we always start by doing that. Yep. Let's see, we could probably move the enum with index in there as well. Should we do that? Yeah, sure. Move the enum with index there as well. It's not really called text anymore. It's lines. Better be accurate in naming things so to make sure we don't get confused later. Okay, so we have lines. And now for these lines, what are we actually trying to compute? Two numbers are not part numbers because they are not, yeah. What is the sum of all part numbers in the engine schematic? Okay, so we want to compute a sum. And we're going to do this by, okay, so we're now going to find all of the part numbers. And we're going to do this by going through the lines. And every time we find a symbol, we're going to find all adjacent part numbers for it. And I bet there's a corner case where the same part number appears multiple times, or where we're supposed to deduplicate this or something of the sort. So, enum map fn line and I. And okay, we are going to take the line, turn it into a char list, and then do enum with index on it. So this should give us, what on earth is, oh, this should give, yeah, this will give us the character, and then the index of it, its index on the line. But then we're going to filter out everything that isn't a symbol. What's a symbol? Symbol, any number adjacent to a symbol. So I'm just going to guess that a symbol is anything that isn't a digit and isn't a dot. Okay, so we want to filter things that are different from dots or different from, okay, so if it's a dot, it doesn't matter. And if it's in a digit, then it also doesn't matter. Will this give us the right thing? No, because filter, I want not this. And I probably need an and here. An and that doesn't make sense. Boolean logic is hard. Okay, let's do this bit by bit. So I want to filter things. Oh, I want to. So if it's a dot, then I don't like it. If it's a digit, then I also don't like it. So now I want to filter out all the things that I don't like. No? Do I just have, no, I should, there's probably a better function to use here, but what is, oh, because of course it's with index, so that's what's going on here. So we have a character and an index. But we only want to do the filtering on characters. Okay, so this will select everything that is a dot or a digit. Well, it certainly did some sort of filtering. And these are digits, and then these are dots. And then it filtered out one thing. Okay, and now I just want to invert this. I think I can just do with list enum reject. Okay, so now it's saying I have a symbol on wait, let's clean this up a bit before we process it further. So enum, oh, so we're mapping here. Okay, so I'm just going to include enum.map. Again, I'm going to have a character and an index which is j, and we're going to map this to character I and J. So we now think there's a symbol on line 1 at character 3. And there is. And then the next symbol is on line 3, 4 on character, oh dear, it's like 1, 2, 0, 3, 4, 7. This is probably a 7. It's a 6. Good enough. Do we have an easier one to check? So on the next one, it should be at character 3. And this is character 3. Okay, so now we have all of the symbols. And for every symbol, we want to find all of the part numbers for them. Enum.flatMap. Oh, this bit by bit. Enum.map. I have a... I don't actually care what the character is, do I? I don't. I just care that it's a symbol. So I don't need to match on that. And now we need to find all of the numbers, all of the spans that are adjacent to I and J. And to do that, we're just going to call a function. Function find adjacent. Let's say I, J, and spans. It has to be in a module. Find adjacent I, J, and spans. And spans has to... N is integer of I and is integer of J and is list of spans. I don't need to add those guards there, but they frequently find annoying bugs in a not particularly typed language like Elixir. Okay, find adjacent. So we're going to be looking for spans on the line above, so on I minus 1, I and I plus 1. And then we're going to be looking for J minus 1, J, J plus 1. So we need to check these three. We're going to have to find spans on these three, on these combination of things. Okay, so we're going to do this with for span I in I minus 1, I plus 1 to end. How do ranges work in Elixir? What happens if let's try it out. So what's 2 to 4? Cannot compile, what does it not like? Doesn't like the 4, right? It's Elixir, so you have to do it like this, don't you? Yes, 2 to 4. And then to list. Okay, 2, 3, 4. So ranges are inclusive on both ends. Ranges are inclusive on both ends. Let's add parentheses here because I don't know how strongly the range operator binds. Right. So span I is where we're looking for the span. And span J is going to be J minus 1, J and J plus 1. However, let's just say okay again here. What do our spans look like? IO inspect. So our spans look like this. So I can easily pick out the line, but then for every line I have a list of things. So then I want to go through the list and check if span J intersects those spans. Okay. Do we have a range intersect or something in Elixir? Elixir. Do we have a range module in general? We have a range module. Do we have an intersect? Checks if two ranges are disjoint. Well, this is the opposite of what I wanted, but the opposite also works. So here we're going to do span j is j minus 1 dot dot j plus 1. And then here we're going to do for no, this is an enum here because we have a list. So enum dot map. What are we going over? We're going over spans of span I. Although it's possible that that we don't have any numbers on that line, so we have to do span map.get span I, and the default value is going to be an empty list. So we always get a list now. Enum.map. Okay, so now we have all of the spans. And the span is a number and then num I and num j. This is, yeah, we're going to change the naming scheme a bit later. So now the question is, does range disjoint of span j and num I to num j. Are these two ranges disjoint? If they are disjoint, then I don't actually like this. Okay, so this is not a map, this is in fact a filter. This is in fact a reject. I want to reject all of the spans that are disjoint with my potential match. Does this actually return something? Find adjacent. Oh, it's saying that this is actually not a list, this is actually a map. Up. I want to see what this actually returns before I go any further, because this was tricky to write. So no function clause matching anonymous function. So the anonymous function on line 23. The anonymous function on line 23, right, because I said earlier that this is always a tuple. And in hindsight, really, it should be a range. Okay, and this returned a bunch of crap. But hopefully only the actual part numbers are in this result. Why is it so nested? It's so nested because we have a bunch of fors here, and really this should be enums and maps. Enums and flat maps. But anyway, let's see if we get the right number. So 460, 467, and 35. 467 and 35. Yes, the next one is 35 because we don't have 114. Then 633 and 617. 633 and 617. Yep. Then it says 592. Yep. It skipped over 58 because that's not adjacent. Then it should be all of 755, 664, 664, 755, and 598. Yep. All right, so this kind of works, although this is very much not the shape of the result we want. So let's not do fors, let's do enum flat maps. Enum flat map, because we know we're going to be returning a list of some sort there. And okay, and then here, bam. Yeah, let's put this on the next line. Does this still compile or does it error out? There's a missing end, right? There is indeed a missing end. Okay, we have less things. So I think we need another flat map here. Okay, even fewer maps. This is kind of the right structure, but we still have empty lines. Or empty lists? Where is empty list coming from? And why is this giving me a warning? Will it tell me? No, it won't. So where are we getting the empty lists from? Presumably we're getting them from here? No, because if this returns an empty list, then this will just reject it. Then this will flatten it entirely. Oh, we're getting an empty list from lines here? Because we're going over every line, right, and we only have a result for the lines with symbols on them? Is that what's going on? So we don't have a symbol on the first and third lines. First and third lines, and then we don't have a symbol on 2 lines in the middle and on the line at the end. 2 lines in the middle and the line at the end. Okay. So this is giving us all of the part numbers. Are any of them doubled? They probably are, aren't they? Because they're not adjacent. What is the sum of all the part numbers in the engine schematic? Yeah, so I'm pretty sure that this means we're not supposed to double count numbers if they appear next to multiple symbols. So, well, let's do it the really lame way, and we're going to flatten this once more. Why is there an end here? Map. Okay, oh, I can do a flat map here? Does this work? Flat map. Yes, okay, now I have a list. And next I'm going to dedupe it. And then surely an Elixir has a dedupe function. Enumerates the enumerable, returning a list where all consecutive duplicate elements are collapsed. Alright, so first we need to sort, then we need to dedupe. And then dot sort. They're sorted. We don't particularly care what the sorting criteria is because, well, whatever it is, we're still going to get the same spans. Actually, let's check this on, instead of example 1, let's do actual input. Am I right in my assumption that there will be duplicates? No, I don't have input yet. Is this day 3 input? Yes. This is day 3. Paste there. Clear my clipboard to avoid the Livebook bug, or probably more accurately say the Firefox bug. Alright, we don't need this an IO inspect here anymore. And now, are there any duplicates? Well, for starters, we don't actually see the whole list, which is a bit frustrating. Can we IO inspect it? Will IO inspect just show us the whole list? It will not. Is there IO inspect? Is there some parameter we can pass to this? Opts. Inspect.opts for a full list of remaining formatting. Inspect fun. Limit. Limits the number of items that are inspected. Nope. Printable limit. Limits the number of characters that are inspected or print on printable strings. Save structs. Oh, this is annoying. But we can hack something on ourselves. First off, is the answer we're looking for already here? Doesn't look like it. Nope, I don't see any duplicates. I can just check if there are duplicates, can't I? But I just need to do part numbers equals this. Right. Why does it keep saying none? Right, I don't care about the number here. Anyway, so I have the part numbers, and now I can just print the length of the part numbers. Right? And what happens if I print the length of the part numbers with unique, after they've been uniqued? Oh, there were no duplicates. Well, better safe than sorry. In that case, we just have to print what? Part numbers. And then dot unique. I wonder if there were actually unique things, and I'm just not accounting for that. Well, we're going to find out if the answer is wrong. Okay, enum.unique, and I'm going to do enum.map fn. This is going to give me a number and the span. I don't care about the span. I just want the number. Yep. And enum.sum. And what was this thing for the example first? Let's check if that worked. Example 1, 4361. 4361. Okay, and now for the input. 538046. 538046. 538046. 538046. That's the right answer. You have 1 gold star. Okay, part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola has the phone labeled help, so you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer, holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part... tomorrow's story is probably going to be that the gondola left without us after we fixed it. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any symbol with the star symbol. A gear is any star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those 2 numbers together. This time, you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. Consider the engine schematic again. Is this the same one as before? 467, yep. In this schematic there are 2 gears. What are the gears? This is one gear here, and then this is the other gear here. The first is in the top left. It has the part numbers 467 and 35. 467 and 35, so its gear ratio is that. We'll trust them. And the second gear is in the lower right. 755 and... second gear is in the right. Is this actually the right number? 755 times 598. 755 times 598. 451490. 451490. Okay. The star adjacent to 617 is not a gear because it's only adjacent to one part number. Adding up all the gear ratios produces this. What's a gear ratio again? The gear ratio is the result of multiplying those 2 numbers together. And then what is the sum of all the gear ratios in your schematic? Okay, so we have to find just the stars that are adjacent to 2 spans. That's pretty easy to do for us, actually. Right? Yeah. So block, new block, this is going to be part 2. We're going to need Elixir. And we can copy a bunch of stuff from here. So we still need the lines. We still need the spans. We're just going to do something different with part numbers. So paste. Let's work on the example. Let's work on the example for now. It's not called example, it's called example 1. Okay, and we have the spans again. So next we need to do something similar to what we did here. Let's start from scratch, shall we? Now let's copy it. And I'm not going to do the deduplication thing again because I know that all the part numbers are unique, so the subset for gears should also be unique. And it shouldn't matter because we're going to be multiplying them together this time. All right, so we start with lines. We go over each line. Each line we convert to a char list with an index. Then we reject anything that... This time we're going to reject anything that isn't... We're just going to filter for stars. Filter for stars. Yeah. And then we're going to map this to create, to get the star and its coordinates. So we get 3 stars. First star is at 1, 3. Next one is at 4, 3. So 1, 3, and then... Did it say 4, 3? Yeah, 0, 1, 2, 3, 4. 4 and 3. Okay, and then the last one is going to be something like 9, 6. Or 9, 5, probably. 8, 5. Close enough. All right. So we have the stars. Next we need... Well, interestingly enough, next we can do find adjacent again, can't we? .map. What's it called? And I think this time we're just not going to do the flat map. That's probably going to be the significant difference. So I don't care about the character, I care about I and J. And then I'm going to do AoC, find adjacent, I, J, and spans. What will this give me? This will give me an error. Why is this an error? The second argument... Oh, because it's Elixir, so tuple syntax is curly brackets, not round brackets. Good. So now for every span, for every star, we should get the list of adjacent spans. And indeed, we have 2 adjacent spans for the first one, only 1 adjacent span for the second one, and 2 adjacent spans for the third one. Right? Like this is 617 is the one we're ignoring. 617 is indeed the one we're ignoring. Right, and now we just need to filter for the lists that are exactly length 2. Right, so we want length of the first parameter is 2. Okay, and now we just need to multiply these. Right, now we're matching, we know that it's going to be exactly 2 elements long, so we're going to have n1 and its span, and n2 and its span. And we're just going to return n1 times n2. Yeah, is this the right thing? 1633345, 1633345, and 591490. What did I just say? 451490. 451490. Okay. And now we just have to sum these. And I don't need to give this a name anymore. We can de-indent this. 467835. 467835. All right. So now does this work for the actual input, or does it error out? Big number, Livebook bug, shouldn't matter. That's the right answer. All right. So day 2 complete. That's lucky. All right. So let's just do a bit of cleanup here. I reloaded in order to get past the Livebook bug. Is this actually return to your advent calendar? Huh, it's actually drawing something. Last year I think it was a Christmas tree. This is a snowman maybe? Or a sleigh? We'll see. But first off, we've got a lot of duplicated stuff in both sections. Right, so let's deduplicate, right? We start both sections by doing by computing the lines split across, by splitting the text into lines and then computing the spans on it. So yeah, at a minimum, we can just move this into its own function. I don't like duplicated code for these things because, well, if we ever do any sort of refactoring, we have to remember to do it in two places. So this is going to be called read input, and it's going to take an input. And then it's going to do this whole thing. Yeah, and then here we have to indent this. And I always press enter there, which screws up the entire indentation. Okay, almost done. Okay, and now we have lines and spans. And we're just going to return lines and spans. Does this still compile or did I break it? It compiles, and now here we're going to do input, we're going to do lines and spans equal read input of input. Yes, this is great naming convention, great writing. And if I run it again, then the results shouldn't change. Read input doesn't exist. Of course it doesn't. Okay, and then doing the same refactoring here. Lines and spans equals AoC dot read input input. And the result should not change. It did not change. All right, we have a bit of refactoring done. Next up, let's move this huge module into the helper section above. This is going to require restarting the Livebook because it really won't be happy when the module gets redefined. Yep, doesn't like. So reconnect and setup. Yep, and then okay, it compiled. Results shouldn't change. Results shouldn't change. All right, better. Next up, I am very not thrilled with this, like the naming here, num_i, num_j, because we at this point in this module, at this point in the function, we have to keep track of I and j, span I and span j, and then num_i and num_j. And what here is avoidable? So I and j, we need them because we need them broken apart so that we can do further manipulation on them. We need span j, we need to construct span j at this point because, well, we are constructing it at this point. But this here, this is our choice. So, okay, so here, when we construct above, instead of representing spans as tuples, we're going to represent them as ranges. Yep. In case anyone's wondering what happened there when my screen moved up and down really quickly, I pressed escape one too many times, so then I went into the normal mode for the Livebook rather than for this particular editor. Yeah, and that just caused me to scroll up and scroll down abruptly. Right. So now we have So now we're going to be returning the spans as actual ranges rather than... Yep, so now here we have num span instead of num I and j. Here we have num span. And if I run this, it shouldn't error out. And if I run it here, it should give the same result. Yes. And same result here. Yes, all right. Anything else we can clean up here? We don't need this comment anymore. Define numbers thing is fine. This is honestly rather tricky to write, but, well, I don't think we have any way of getting around doing these plus ones and minus ones, so this would probably have to be like this. You can probably get rid of some of the matches by more selectively, by discarding information earlier, but that will make everything harder to debug. We could probably combine a bunch of these pipelines here, but this shows at least step by step what we're doing. Yeah. Okay, I think this is it. I think I'm going to leave it like this. This is a pretty okay solution. It's not code golfed by any extent, but, well, it gets the job done, and it's readable. It's sufficiently readable for something that only will ever really be read once by me. So that's it. Thanks for tuning in, and see you all tomorrow. Bye-bye.